Today, we're going to learn how to easily make our own batteries from very inexpensive household materials. An AA battery is a standard-sized cylindrical battery commonly used in portable electronic devices. The exact terminal voltage and capacity of an AA-sized battery depends on the cell chemistry, but they're usually rated at or near 1.5 volts. An AA cell measures 49.2 to 50.5 millimeters in length, including the terminal, and 13.5 to 14.5 millimeters in diameter. AA battery sales account for over 50% of general battery sales, and the average price of a quality AA battery can range from 59 cents to as much as $1.42 or more. Do you think this would be helpful in an emergency? Is this a viable and renewable source of energy? Would this be a good way to teach kids about science? Let's find out. To get started, the materials you'll need include one strip of corrugated paper, cardboard box, 12 copper flat washers, size number 10, 14 to 16 zinc flat washers, size number 10 as well, one shrink wrap tubing, 2.5 inches by 1 inch, 4 ounces of distilled water, 1 ounce of vinegar, and 4 tablespoons of table salt. You'll also need the following tools: a soldering iron, solder, a mixing bowl, digital multimeter, scissors, sandpaper, needle nose pliers, a lighter or heat gun, and an old AA battery for reference. First, we'll prepare the copper and zinc. The copper and zinc flat washers are going to serve as your anodes and cathodes for your battery, separated by an electrolyte. This battery will be constructed of 11 cells in series to create a robust 1.5 volts. The copper and zinc washers should be clean, free of debris, and roughened with a 100 grit sandpaper, and then wiped until brilliant and shiny. Next, we'll cut our cardboard. We'll be cutting our corrugated paper into 11 squares. These will serve as a tiny sponge to absorb and suspend the electrolyte between our copper and zinc anodes and cathodes. When cutting the cardboard squares, be sure they're precisely the size of the washers. If they're too large, they'll create a short, and if they're too small, they will not hold sufficient electrolyte. When finished, put them to the side. Next, we'll prepare the electrolyte. Voltage is a potential difference, which we find with copper and zinc. The electrolyte is the medium through which this charge can pass. To prepare the electrolyte, first stir the 4 tablespoons of table salt into the 4 ounces of distilled water until the water has reached its maximum salinity and the salt no longer dissolves. The water should have a milky white appearance. Be sure to mix thoroughly before adding vinegar. Once settled, add 1 ounce of vinegar. Mix and allow it to sit. Once your electrolyte mix has been left to stand for approximately 5 minutes, you can insert your cardboard squares to let soak. Be sure to submerge all the squares, stir, and allow them to float until they are ready to use. To ensure a tight fit, we have selected a shrink wrap that is slightly smaller in diameter than our washers. We will need to stretch it temporarily in order to insert our washers in paper squares. Okay. Insert the needle-nosed pliers and open them slowly while working them around until stretched to 110% in diameter. Repeat on the other side. A washer should now fit snugly when placed in the tube horizontally. Next, we're going to test our components. As discussed, we will be building 11 cells consisting of copper, electrolyte, and zinc. Before constructing our battery, we will make one cell to test our components. Simply stack 1 copper washer, 1 soaked cardboard square, and top it with 1 zinc washer. Next, we will test it with our digital multimeter. The red wire should be in the voltage slot, the black wire in the COM slot, and the multimeter should be set at or near 20 volts DC. Then, contact the black lead to the copper washer and the red lead to the zinc, making sure they are isolated and not touching each other or anything else. You should now see a display of somewhere between 0.05 and 0.15 volts. If your reading is higher than this, don't worry. The voltage may climb, but will then reduce. If your reading is lower than this, check your components and try again. If your reading is 0, check your contacts and make sure your multimeter is set correctly. Next, we'll plan the core build. Before getting started, take a look at this image showing how the construction of the cells will make your battery. Notice the order: copper, zinc, electrolyte, repeat. Now we'll build our core. To build the core, we will be stacking the components, making sure they are flat, without spaces, and without compressing the electrolyte mixture out. First, insert a copper washer, putting it 1/4 inch from the end and making sure it is horizontally straight. Next, drop a zinc washer on top and then add one of your soaked electrolyte squares. It is helpful to have a pen or a nail to push the cardboard down evenly. Just be sure not to press too hard. Then repeat: copper, zinc, electrolyte, tap down, copper, zinc, electrolyte, tap down, until the last zinc washer tops the stack. Before sealing your battery, compare to a standard AA battery to ensure the correct length. If necessary, add additional zinc washers until the correct length is reached. Note that the protruding nub on the positive side will be added later with solder. Once the correct length is reached, begin heating the end that you are starting with. Make sure to make a tight seal. Next, heat the sides of your battery until the heat shrink tube tightly contours to the ripples of the washers. Then, trim the excess, leaving only a 1/4 inch, and heat until a tight seal is formed on the other end as well. Now we'll add our terminals. Plug in your soldering iron and wait until hot. Secure your battery copper side up, the side you started with. You will then apply heat to the solder while holding it above the hole formed on the end of your battery. As it melts, press the solder into the hole until full and finish with a small bead of solder on top. Once cool, flip your battery over so the zinc side is up. If you added additional washers, this side will require quite a bit more solder. Repeat the process until full and top with a large bead of solder to signify the positive side. More or less solder can be added at this point to exactly match the correct length. Now you're done. It's time to test it. Your battery is now complete. If you've done everything correctly, you should be able to attach your multimeter with the same setting as before and get a reading at or around 1.5 volts. Compare it to a standard AA battery to see how you did. For troubleshooting, it is normal for your voltage to be high at first and then level out. If your voltage is slightly low, try pulling the battery gently from the ends to stretch it slightly. If your voltage is very low, you may have a short. Electrolyte square may be misaligned, or you may have stacked the components in the wrong order. If everything's working properly, it's time to use your new battery. Your battery will fit into any standard AA slot and will provide the voltage you need to power all of your favorite gadgets. This homemade battery can power LED flashlights, portable recording devices, your computer mouse, or any other device that requires AA batteries. Now that you can make your own batteries at home, you'll never need to buy expensive store-bought batteries again. See more at drewpauldesigns.com.